Welcome back, student. So now that we have covered installing Kubernetes dashboard, let's finally deploy some application on EKS cluster, because we have created EKS cluster in chapter 1, but we have digressed to Helm chart and a Kubernetes dashboard. Now is the time to actually deploy some workloads and then see some application running on the EKS cluster. So that's what we're going to do in this chapter. So what we're going to do is to use this guest book application, sample application available on the public GitHub. This is the architecture diagram. It's going to be fronting address load balancer of service type load balancer. There's a guestbook application pod with 2 replicas, and it writes to Redis master pod. And there's also Redis slave pod that are providing read services for the performance sake. So front end, this guestbook app is using PHP. It's load balanced by AWS load balancer, classic load balancer. So read request load balance to Redis slave pod. So if you want to read some data, it goes to Redis slave pod to offload some of the workload from Redis master pod, which does writing, which is like a heavy load. And the write request to database goes to Redis master pod. And backend wise, there's a single master that allows write to Redis, and also multiple slave Redis pods, which does read. And slave Redis pods sync continuously from master node. Okay, so first section, let's deploy Redis master. So we are going to chapter 5, so go back to root and then go to 5, deploy app, list, nothing, shell clear. So let's deploy Redis master. So we have YAML files available on the internet, so you can go to this link from browser, and it's going to show you a raw JSON file. What this is going to deploy is metadata, kind is the replication controller, and here's the spec, pod spec here, Redis master, image tag is Redis 2823, and the port 6379 is open. So we're going to do that here. Left hand side, I have a kubeproxy tab open so that I can see a Kubernetes dashboard here. And the right hand side, it's watching deployment, pod, and a service every 2 seconds. So I'm going to deploy this one, Redis master controller, enter. What it's going to do, it's going to show the application controller and a pod here. Yes, it's created. And after that, I'm going to expose this service inside the cluster using Redis master service of JSON. So enter. If you want to see what is the definition of this JSON, you can go to this URL. You see spec of kind service, port 6379. Because it doesn't say anything about type, it defaults to cluster IP, which is available only inside the cluster. Now, inside dashboard, you can see pod 1 available, Redis master, and also service should be available because I just created it. So go to service. Where is service? Service here. You're going to see Redis master as well, right? So right now I created Redis master pod and a Redis master service. We are going to deploy Redis slave. So I'm going to just copy paste 2 of them, paste it in, do apply, 1 each. It's going to create a slave, which are these 2. Expose this in a cluster using a cluster IP. So right now you should be able to see 3 pods, Redis master, Redis slaves with 2 replicas, and Redis slave service as well. So here you see Redis slave service, and also this is pod, Redis slave, 2 replicas, and also service wise Redis slave as well. Cool, right? So right now here, default, there are 3 pods here. Now database is created. Let's deploy front end. So guestbook controller, this is doing a replication controller, and also service, which is going to be service of load balancer. So service of load balancer to create a load balancer on AWS, and this is a replication, so that has some high availability. So we're going to do that, copy paste and enter, create service. So there should be service available. After a while, it's going to show up here. Right now it's Redis master and slave, but guestbook service is going to show up. Enter. Yes, guestbook. It should show up here after a while. If not, let's debug this one. So right now, guestbook, 3 pods are being created as a replica. Let's take a look at service. So service is not being created, at least in default namespace. Maybe kube system. Let's say all namespaces. Where is guestbook? Guestbook is not being created. Let's take a look at this JSON. Maybe it's creating in different namespace. I'm not sure. Guestbook service of type load balancer. Namespace is not specified, so it should be creating in default namespace, but I don't see it here. Default doesn't see guestbook. I want to know the reason. So I'll do that again. kubectl, apply. Let's do delete. So it seems like it's created something not found. So I'll do kubectl, apply, -f, it should create a guestbook service here. So it's created. 2 seconds after, it's gonna show up, yes. And this is the AWS load balancer's public DNS. This one, it's gonna show up here. And if I refresh, yes, this one. It's created right now. And type is classic load balancer. And this is a layer 4. Classic load balancer itself is a layer 7 load balancer, but in Kubernetes, it doesn't really use HTTP path or host to split traffic. So right now it says, hey, it's distributing to this one, but status out of service. Why? Because it takes about 5 minutes to warm up load balancer usually. So if I go to load balancer DNS here, nothing. If I curl, and then curl could not resolve this host because it doesn't exist yet. It takes 5 minutes. Curl URL -- bubbles and show yeah, it cannot resolve even this one. So DNS is not working yet. Right now it's been 74 seconds, about 1 minute. It takes about 3 more minutes to be able to access this one. So don't freak out if you go to this public DNS of a load balancer and you get this one. It's normal. So right now, load balancer is being created. Health check, instance, in service. See, this one was out of service earlier. Now in service, but not yet. Because I think DNS is not resolving yet. See, cannot resolve this one. Need to wait out a little bit more. In terms of Kubernetes dashboard, right now I see guestbook service, which is cool. And this one showing, hey, this is a backend pods. From this load balancer, it's gonna distribute traffic to these backend pods, like 3 replicas. Load balancer of type, go to overview, pod, 6 pods because of 3 guestbook here, and then 2 slaves and 1 master. So right now I have successfully deployed this entire application here, although we need to wait for a load balancer to be available. So scroll down. So we just deployed that one, right? And if we do kubectl get replication controller, if we do kubectl get replication controller, we're gonna see 3 replication controller, guestbook, Redis master, slave. If we want to get service and pod, we're gonna do kubectl get pod, which is what we see here already using the watch command. Can do kubectl get service, and we're gonna see these 3 services: guestbook, master, slave. This is the default service to Kubernetes API endpoint. All right, so everything's running. We want to get service load balancer's public DNS, which we can just copy paste it from here, right? But we can do this from command as well. So if we do, that's what this command is doing. Basically, if we do kubectl get service, it's gonna show us a column table, right? If you do this, kubectl get service, org command is gonna cut out and then pick this column 4 by specifying this here. It's gonna show us this external IP. Now we can do is pipe this one using a tail command, tail-1 to get the last line. This is the first line, this is the second line, last line. So we do this one, tail-1 to return public DNS. Probably at this point, it should be available. Refresh. Yes, it is available right now. It's loading. Takes time. If we do curl, should be able to resolve. Yeah, right now, if I do curl, verbose, it's trying to connect to this public IP. It's connecting, but it's slow. Okay. And also, we need to be careful about which port it's being, it returned something, close connection. Okay. Yeah. So I wanted to just say that there's some port being open. So it's not 80, but 3000. So if I do this 3000, it should be connecting. Yeah. So the reason why I need to specify 3000 is because it's from a service definition here. So this service guestbook has a definition. It says bind public 3000 port to cluster node port 32144. And you wonder, where is this defined? This is defined in front-end guestbook service, this JSON file. This file specifies port number. So hey, I'm gonna open up a port 3000 for this service. So you need to go through this 3000 port. If I don't, I cannot access the application. So I need to specify 3000, and that's gonna do that's gonna distribute traffic to a backend. You can also see it from a dashboard. Service, you see guestbook, you're gonna have 3000 open, and this is the node port. This is like an inside cluster port. This is the outside. See, this is the external endpoint. It says colon 3000. So if you click, you go here, same thing. So right now, successfully deployed guestbook application. We can say hello world, and this is just a simple application. It doesn't really matter, but just write data to Redis. Hello from Chrome, and if you refresh, data is gonna be stored in Redis. So this data persists. If you open up new tab, yeah, data is persisting. So this is a cool sample application that we use to demonstrate how to deploy application on EKS cluster. So we have done this one, right? After 3 to 5 minutes, load balance is available. And then lastly, I want to just cover what happened in terms of architecture. Next section, point 4.6, we are going to install Nginx Ingress Controller. This is for demo purpose. We are going to use a traditional approach for installing Ingress Controller as opposed to using Istio Gateway. We're going to do Istio Gateway afterward, just for comparison. So what we're going to do is copy paste these commands, create namespace Nginx Ingress Controller to create a new namespace for Nginx, create it. And we are going to install Nginx Ingress Controller using Helm chart. So to do that, we need to add this custom repo called a Google APIs. So grab this command, paste in, Helm repo add stable, Kubernetes chart storage, Google API.com. And then after that, do Helm repo update to make sure that all the charts are up to date. So right now it's adding a Helm repo. And then you see here, stable has been added to your repositories. So now paste another command called Helm repo update. Okay. And after that, we are going to do copy this command, Helm install Nginx Ingress Controller. And so this is a stable Nginx Ingress, and we are going to install this one under a namespace called Nginx Ingress Controller, which is the one that we created earlier. Okay, so Helm repo update is successful. So we're gonna paste in Helm install Nginx Ingress Controller. This is gonna be a release name. This can be customized, but I'm gonna make it simplified, Nginx Ingress Controller, and then specify stable Nginx Ingress, enter. Okay, so Helm chart is already installed. We do kubectl get pod service in namespace called Nginx Ingress Controller. It's too long, so I'm gonna copy paste it, enter. kubectl, it's a typo here, kubectl, enter. And we should see Nginx pod here, Nginx Ingress Controller pod, and also Nginx Ingress Controller default backend pod, and service. You see here Nginx Ingress Controller, service of load balancer. And it also created another load balancer. We are using AWS EKS, so it created AWS load balancer. So let's take a look on the AWS console here, EC2, and refresh this one. We're gonna see third load balancer at the moment. Don't worry, we're gonna clean this up, and we're gonna end up just having one load balancer. So anyways, this is the most latest one, so created at sort by time. This is the most recently created load balancer, A34, which is the same one as this one. So this is from Nginx Ingress Controller. And this one, A31, this is created by service type of load balancer for guestbook application. So here we see guestbook load balancer, and the DNS starting with A31. And the last one, A35, this is created by installing Istio. Remember we had Istio Ingress Gateway service. So this is for gateway for Istio. This is the Nginx, and this is the service. And what we're gonna do is basically getting rid of this service, and then we're gonna just use Ingress Gateway's load balancer. And after that, we're gonna compare Nginx Ingress Controller with Istio Gateway. And that's why we have two different kinds of gateways or load balancers aside from this service of load balancer. So section 4.7, create ingress resource for layer 7 load balancing by HTTP host and path. So we have already ingress YAML here in this folder. So we are looking at chapter 4, ingress YAML. We have already defined a YAML file for this. So basically we are defining layer 7 load balancing backend path. So we have a backend list and a service name. This is gonna be a backend service name called guestbook, which is the same as this one, service guestbook. And then service port is gonna be 3000 because as you can see, service port is 3000. This is node port. So first, let's try to get this ingress working. So what we're gonna do is kubectl apply -s. So we're gonna create ingress resource by issuing kubectl apply -f ingress YAML. So kubectl apply -f ingress YAML, enter. And basically, this is a layer 7 configuration, and it's good. So what we're gonna do next is to get public DNS of AWS EOB created from this Nginx Ingress Controller Helm chart. To do that, we can copy this command. This is conveniently provided to just print out public DNS of load balancer here. And you can just copy this and go to browser This is from a service of type load balancer, so you still needed to specify node port of service 3000. This is not really intuitive and not easy, so we replaced it with ingress controller. So this is gonna be ingress controller's public DNS and enter. You don't need to specify node port anymore, and then now you can access guestbook as well. So this is easier. You can do hello world again, enter. So ingress controller is deployed, external access also verified. So right now we still have like 3 load balancers, but now we have latest one from an ingress controller. We can get rid of a load balancer created by service of load balancer. So that's this section. Section 4.8. Delete AWS ELB created by Kubernetes service of type load balancer. So now modify guestbook service of type load balancer and then change it to node port. We are talking about this service of guestbook. Right now is type load balancer. We no longer need this load balancer because it's going to be duplicate. So we're going to change this type to a node port. To do that, first we need to do get service guestbook and then -- output YAML to print out YAML file here. Okay, and we are going to save this one. Basically, saved YAML file is this one. So here we have a little bit of metadata. The kind is service, name is guestbook, but stuff like self-link, UID, external traffic policy, cluster IP, status, hostname, blah blah blah. These are metadata added after creation, and we don't need these. So this is the streamlined service YAML file for guestbook for type node port. So we can just use this one, all right? So to do that, we already have this service guestbook node port YAML file. So I just explained this one. Basically, kubectl get service guestbook -YAML is gonna print out this one, which is exactly the same as this one, except a little bit of metadata information. And we're gonna trim some fats in this one, getting rid of the metadata, and it ends up being like this one, right? So strip out status etc, and then I already provided this streamlined YAML file for node port, which is this one. So we're gonna apply this one, but this is gonna be conflicting because service guestbook already exists. So what we're gonna do first is to get rid of a service name guestbook. So scroll down here, copy this command, get kubectl delete service guestbook, and we're gonna get rid of this one. By doing this, we are going to remove one of the 3 load balancers existing right now. So service guestbook deleted. So if you go back to this console, AWS, if you're using AWS EKS again, if you're using GKE, it'll be different. You're using Minikube, it'll be different as well. But right now, we just removed service of type load balancer, so this is gonna be gone. So refresh. Now there are only 2. One is from Nginx ingress controller from Helm chart, and this one is from Istio gateway. That's good. One step at a time. And then now we are going to deploy service guestbook node port, right? So that we can access guestbook again. So now service of node port is provided. It should be working again. Refresh, and now it's working. At this point, we have only 2 load balancers, and eventually we're gonna get rid of this Nginx ingress controller after we do comparison between Istio gateway and ingress. Okay, so 4.8 is good. Service is listed out here. Okay, so section 4.9, what just happened? So we replaced guestbook service of type load balancer to of node port. That's why we only see 2 load balancers right now. Front guestbook service with Nginx ingress controller service of type load balancer. So what I mean by fronting guestbook service with this Nginx ingress controller service type load balancer is, take a look here. This was initial stage of guestbook application. We had a service of guestbook of type load balancer. So this was fronted by classic load balancer. We replaced it with ingress controller. So right now we take a look here. We have guestbook of type node port. As you can see here, guestbook of node port as opposed to load balancer. It used to be connected to load balancer directly, but not anymore, because right now we installed Nginx ingress controller using Helm chart. So the Helm chart created a service of type load balancer. So this is fronted by AWS load balancer, and we have Nginx ingress controller pod within which Nginx is running. And then we also provided this ingress resource file where we define layer 7 load balancing, like a backend guestbook. We did that, right, in the previous chapter. So now service is fronted by Nginx ingress controller. Here is the Nginx. And in front of the Nginx ingress controller is AWS Classic Load Balancer. This is the traditional approach using ingress gateway. We have a service and we have ingress controller. We have one load balancer provided by cloud services like AWS and GKE or GCP. And then we have ingress controller pod within which there's another load balancing application running. Could be Nginx or HA proxy or could be ECTL. And then we have layer 4 load balancing by Kubernetes service. This is normal. What we're going to do, so we just covered about Nginx ingress controller pod. We'll be doing layer 7 load balancing based on HTTP path and host using resource. This is before ingress. This is before ingress. This is after ingress. But what we are interested in because of this course is about ECTL. So this is really what we are getting into. So with ECTL, ingress controller is going to be replaced by ECTL gateway. So let me expand this one to enlarge this diagram a bit more. So you see with ECTL enabled version, this is what's most interesting here. So there are two diagrams, left and right. Left one is a traditional approach, Nginx ingress controller as an example and demonstration illustration purpose, and a service and pod. This is current setup right now. And with the ECTL enabled one, we are going to be replacing this Nginx ingress controller here with ECTL gateway. And then this is going to be ECTL gateway service. And then this part, ingress resource YAML file, is going to be replaced by virtual service. We explained a little bit about virtual service in chapter 1. And this is going to be gateway as opposed to ingress controller. Name is going to be a little bit different. YAML definition is going to be a little bit different. But that's about it. Service is going to stay the same, node port or cluster IP, and pod is going to stay the same. But there's a little difference here as well. We have sidecar envoy proxy container running inside this guestbook pod. We didn't do much for this pod, right? We enabled ECTL injection by adding label to namespace in chapter 2. Whenever we deploy these pods, ECTL sidecar envoy proxy is going to be injected automatically to pod. This is only the case when you are deploying applications after enabling injection, meaning that if you already deploy application while namespace isn't enabled for ECTL injection, then this sidecar is not going to be injected. So the order of execution should be first, you need to enable namespace, and then second, you deploy application. You cannot just deploy application and then enable namespace. ECTL sidecar injection cannot be done for existing pods. So if you want to add sidecar, you need to redeploy existing applications, okay? But anyways, with the ECTL approach, this ingress controller and also ingress YAML file are going to be replaced by gateway and a virtual service. So this is what we're going to do in the next chapter. So we're going to dive deep into a gateway and a virtual service YAML file to really expose this guestbook application now using gateway as opposed to ingress controller. So this is like a baby step by step. So we have come from without ingress and now using ingress. And chapter 5 is going to be about using ECTL gateway and virtual service. Okay, so this is chapter 5. We are going to be exposing service using ECTL virtual service and also gateway. So we're going to be transitioning from Kubernetes ingress to ECTL gateway as already mentioned at the end of the last chapter. So section 5.1, what is gateway? So let me explain with this diagram about what is gateway in a high level. So take a look at this diagram. Left hand side is the ingress controller. This is a traditional approach. This is the Nginx controller. Right hand side is ECTL gateway enabled diagram. So this Nginx got replaced by ECTL ingress gateway. And if you enlarge this pod, what you see inside this pod is just one standalone envoy proxy. So this is a standalone case. Other applications pods like a guestbook pods in the backend, if you enlarge this pod, you're gonna see two containers, at least minimum two containers, depending on how many containers you have for application. But for this sample guestbook, we have a guestbook container and also there's a sidecar envoy proxy. So this is a reason why this is called a sidecar, because this envoy proxy was injected right next to a main application container. So this is a sidecar approach. Whereas this ingress gateway pod wise, this is a standalone one. There's only one container inside this pod. This is the only exceptions. So this is the gateway, just replacing ingress controller with Istio ingress gateway, and an envoy is going to do a layer 7 load balancing using a virtual service here. But anyways, that's enough for a high-level overview of gateway. So to recap, gateway is a load balancer. So this is the excerpt from our website documentation page. So gateway describes a load balancer operating at the edge of the mesh, receiving incoming and outgoing HTTP and TCP connection. This is what I mean earlier about the edge of the mesh. This one is sitting at the edge of the service mesh because this is the kind of like a load balancing proxy at the boundary of the service mesh. So this is the edge proxy, sometimes called it. And also, gateway runs as a standalone envoy proxy inside a pod. I've also mentioned about standalone envoy proxy, and gateway configurations are applied to standalone envoy proxies that are running at the edge of the service mesh, rather than sidecar envoy proxies running alongside your service workloads. And you can take a look at the actual ingress gateway pod in the Istio system. So you can do get pod, namespace Istio service, namespace Istio system, and a -- label Istio ingress gateway. We've already seen this one in chapter 2, but you can do this again. Get pod in namespace Istio system, label Istio equal ingress gateway. This is the actual pod. This is the same one as this ingress gateway pod. Inside this one is only one envoy proxy. So this is a standalone case. So notice one out of one. So there's only one container inside the pod, and this is a reason why it's called a standalone envoy proxy. Whereas other ones like this one, you see guestbook ready 2 out of 2. This one is same as this backend guestbook pod. This one is 2, meaning that there's a sidecar envoy proxy along with a guestbook container. And that's that. Gateway is really just similar to AWS EOB listener or just Nginx ingress controller in that this defines incoming ports, protocol, and also target groups. Gateway configured set of ports that should be exposed externally, type of protocol to use, for example like HTTP, HTTPS, and TCP, and also here using SNI, service name invocation. You can do service name configuration for load balancer in a gateway YAML file. And also, of course, you can configure TLS or SSL configuration for supporting HTTPS traffic. This is So section 5.2, Gateway Anatomy. In this section, we are going to analyze and break down gateway YAML file. So for example, the below gateway YAML file, which is this one, will be applied to the envoy proxy running on a pod at the edge of the service mesh with the labels Istio ingress gateway. This is basically exactly the same as this one, because inside this one is going to be envoy proxy. So if you do kubectl describe pod, then name the pod, namespace Istio system, enter. And then we are going to be describing this pod, and inside this one you're going to see container image envoy proxy 2.1.6.7. This is Istio proxy is a named container, and this is really just an envoy proxy. There's only one container inside, and you can also see a label which is Istio ingress gateway. So basically this is talking about this one. This is a little bit of verbose explanation, but it says envoy proxy running on a pod at the edge of the service mesh with a label this one, which is basically this one, which was pre-configured gateway proxy when we were doing installation of Istio using a profile demo. I remember there was a table in chapter 2 about a bunch of components that are coming with a profile. So demo included ingress, egress, and also add-ons like Grafana, Prometheus, and Kiali, and Yaga. So this was already installed because we used a profile demo in chapter 2. And also in this YAML file is going to let HTTP traffic from a host wildcard asterisk into the service mesh on port 80. So this is really just defining what incoming port and what incoming protocol for what DNS host for this gateway to accept. So this kind gateway, this really resembles AWS load balancer's listener configuration, which defines incoming port and protocol and also a backend target group. So basically this is just that, Gateway is just defining incoming port and protocol, and a little bit more explanations about these attributes. Host, for example, one or more hosts exposed by this gateway. So this gateway can expose multiple hosts. While typically applicable to HTTP services, this can also be used for TCP services using TLS with SNI, service name invocation. This is where you're trying to enable HTTPS for different hosts. And also, a host is specified as a DNS name with a optional namespace / prefix. So let's say we have example.com, and we also want to prefix namespace. In this case, you can do staging / example.com. Also, a virtual service must be bound to the gateway and must have one or more hosts that are matching with hosts specified in this server configuration. And about the port, we have number, protocol. Protocol must be one of the HTTP, HTTPS, gRPC, HTTP2, Mongo, TCP, TLS. And the TLS implies the connection will be routed based on a SNI header to the destination without terminating TLS connection. So this means if you use protocol TLS, basically we're going to be doing a SSL pass-through. And a name, this is just a label assigned to this port. So this can be customized. You can say HTTP or HTTPS. But as mentioned here, a virtual service must be bound to the gateway. It's the same thing here. However, for the gateway to work as intended, you must also bind the gateway to a virtual service. So this is the next section here. Virtual service, because gateway cannot be just used by itself. You also need to deploy virtual service to make it work. But anyways, this is the analogy, something like this one. I mentioned this twice at least, but AWS EOB listener looks exactly like Istio Gateway, whereas AWS Elastic Load Balancer's target group, which defines backend layer 7 host and path, protocol, and backends, this is exactly the job of Istio Virtual Service, which we're going to talk about in the next section, which defines layer 7 path and host, protocol, TLS, and also backend services. Okay, so section 5.3, what is a virtual service? You can just think about this virtual service as a replacement for ingress resource YAML file. This defines a layer 7 host, path, and also backend service file. So nothing really changed in this diagram, just we have already talked about ingress gateway. This is the Istio gateway, and then behind that we're gonna be using a virtual service to bind this one to gateway so that actual layer 7 routing works. So here's a linear view diagram of this architecture. I thought this would be really helpful because first time learning Istio for me, it was pretty confusing. So this is the external internet, and this green boundary, this rectangle, is indicating AWS VPC boundary. And inside AWS VPC, again, we are talking about AWS EKS. Just replace concepts with a GKE concept, or if you're using Microsoft Azure or Minikube. But anyways, either way, we have internet gateway, and we have load balancer, and we have ingress gateways service, which is of type load balancer, and therefore serviceable load balancer created this load balancer in public cloud. And then we have ingress gateway pod, which we look at in the terminal earlier. And then we need to bind virtual service with this gateway. So we've already talked about this gateway YAML in the previous section. Gateway YAML just defines an incoming port 80 in this example, and protocol will be HTTP, and also define a host as a wildcard in this example. And then we are going to be adding this virtual service YAML file. And what this defines is subsets of hosts that you want to expose using a backend service. This is the host configuration. And then we also need to specify gateways. Gateway name is gonna be, in this example, guestbook gateway, which is the same as this one. So you can have multiple gateway YAML files. So number of gateways is not just one, can be many. And then this gateway is referencing the actual service, this Istio ingress service, which is already created by installing Istio using a demo profile, has a label called Istio ingress gateway. This is the service of type load balancer, and therefore this created load balancer. So you can have multiple gateway YAML file here, and then it can reference the same a load balancer, which is really just this one. But so depending on different applications or different applications in namespace, or could be in a different environment, you can have multiple gateways to have kind of a decoupled configurations. So we can have multiple gateways, and also we can have multiple virtual services, and this virtual service can reference one of the gateways, which can reference ingress gateway. And then here we have HTTP block. This is really similar to ingress resource YAML file. That one had also a HTTP block with a little bit of a key value naming is a little bit different, but basically the same thing. In this Istio virtual service case, it has route, destination, host is guestbook, and a port 3000. This is the service port, and host name is gonna be service name. So it's gonna be this service. This is the Kubernetes service YAML file, and this service file is registered in Istio service registry. So all the Kubernetes services that are inside the Kubernetes cluster are going to be automatically added to Istio service registry. So this is gonna look up service registry, and then this is in fact the same one as a service name in a default namespace. So this is how it works. Virtual service is going to reference gateway YAML file's name, and then gateway is going to reference ingress gateways labeled by Istio ingress gateway. So it's kind of like a cascading way, but in backwards. And this was a little bit confusing because in ingress controller, you don't need to really specify like this one, like service and then gateway in a virtual service. So I thought this linear view is going to be a little bit more helpful. So this diagram is a little bit small, so I'm going to explain using a YAML file. But to summarize in textual information, you can customize routing behaviors by using virtual service to tell Envoy how to send virtual services traffic to appropriate destinations. So this is where Istio comes in. With this virtual service YAML file, we can enable a lot of features. For example, we have already covered most of the Istio features in chapter 1 in an intro about benefits of Istio, and one of them are listed out here. For example, 20% of codes goes to new version. This is talking about canary release. Also, codes from these users go to version 2. This is based on an identity or HTTP based routing. You can enable these using a virtual service. Also, we can do, for example, 30%. This is just an example though. The number is arbitrary. 30% request will return HTTP 400. This is talking about fault injection. Also, 10% request will have timeout of 5 seconds introduced. So this is about setting timeout and etc. So virtual service is going to be a configuration YAML file where we can define a lot of these features. Ingress resource file couldn't do it. With Istio virtual service, you can. Let's talk about virtual service YAML file anatomy in section 5.4. So this is a typical virtual service YAML file. So I've already kind of explained in this diagram, but it was a little bit small to hard to read probably. And this is pretty much the same thing. This is still Kubernetes YAML file, but this is a custom object. So kind is virtual service, metadata, names and views. This is okay. And what's interesting is the spec section. There's the first one is called a host. So in this host, you can define destinations that these routing rules apply to. This is a list of addresses that client uses when sending requests to the service. What this means is that we have the views in a host list, and the views should be listed out in upstream gateway YAML file. Because gateway YAML file's host was specifying wildcard, so it can be anything. But whereas this one, virtual service, needs to specify actual host name. It could be reviews. And then we have HTTP section. This is where layer 7 load balancing happens. And this is an example using a condition matching. So we have a match and also route. When header contains end user equal JSON, then do route as following. This is how you read it. So this is the parent object, and then this is the child one. We have top level route and also second level route, and this route is only under this match condition, whereas this one is a global. So it says global. This is kind of like a fallback routing route to a destination host called reviews. This is a Kubernetes short name, or it could be fully qualified domain name. For example, like reviews default.service cluster local. That'll be fully qualified domain name. You can also use short name, and also using subset we're gonna explain subset in coming sections, but this is basically you can use different versions of a deployment. So this is using version 3 of reviews. This is a global routing, whereas if header contains end user JSON, then you can route to reviews version 2. So this is an example of identity or HTTP header based routing. And here, a little bit of explanation here. Host can be IP address, DNS name, or Kubernetes service short name or fully qualified domain name, or wildcard prefixes. When a short Kubernetes service name is evaluated, Istio adds a domain suffix based on the namespace of virtual service. This is kind of a little bit important. So when, for example, using Kubernetes short name reviews, then Istio is going to add namespace of this virtual service, not the namespace of this reviews. So if this one is inside, let's say, default, then Istio is going to add reviews.default. Whereas this one was created in, let's say, staging, then review is going to be actually going to be reviews.staging. So this is something to remember, because when you're debugging and somehow traffic doesn't get routed to correct reviews in the correct namespace, then this is something to kind of keep back in your mind. So next, this is a HTTP section, which is this one. So this one can contain match condition and also route destination. So this route destination specifies the actual destination for traffic that matches this condition. So unlike virtual services host, I'm talking about this host. This could be fictitious host name. That's what I'm talking about here. Virtual services host can be fictitious, whereas this destination host, which is this one, destination host, this must be a real destination that exists in Istio's service registry, or else Envoy wouldn't know where to send traffic to it. So this can be either a mesh service, which means that Kubernetes service inside the Istio service mesh, because all the Kubernetes services inside Istio service mesh are added to Istio service registry by default. Whereas if they are not mesh service, meaning that they're external ones, they need to be added using service entry. So what I mean by that is that, for example, external DNS endpoint, for example, AWS RDS, or it could be GKE database endpoint, which is outside of an Istio service registry, they need to be added by creating Istio service entry so that Istio knows where those are, because they are outside of an Istio service mesh. Therefore, service registry doesn't know the endpoint. Right, and the other bit note I've already mentioned, using short name works only if both the destination hosts in the virtual services are actually in the same Kubernetes namespace. This is what I talked about. So that means, irrespective of namespace within which this service exists, namespace of the virtual service is going to be appended. So be careful with this one. And also, another note is that routing rules are evaluated in sequential order from top to bottom. This means that in the above example, there's the first one is evaluated and the second one is evaluated in this way. Okay, so section 5.5, we're going to deploy Istio Virtual Service and also Istio Gateway. So mapping between Kubernetes Ingress Controller, Ingress Resource, and Istio Gateway and Istio Virtual Service is as following. I've already mentioned about this a couple of times before, but basically, Ingress Controller is getting replaced by Istio Gateway, and Ingress Resource YAML file is basically replaced by Virtual Service. So we have two YAML files. One is Gateway, kind Gateway, and another one is kind of virtual service. So we're going to be replacing Nginx Ingress Controller with this kind, with this gateway, guestbook gateway, and we're going to replace Ingress resource file that we created in a previous chapter with this new virtual service, where we define layer 7 load balancing rules. So I've already explained about anatomy of a virtual service here. So for guestbook, it's going to be pretty similar to Ingress resource YAML file. So HTTP block where we have match condition list, where URI is specifying prefix / basically this is a root path, and any request with HTTP path pointing to this /, then we want the request to be routed to backend guestbook service. We can either specify guestbook backend service using a shorthand name or using a fully qualified domain name like this one. So guestbook followed by namespace name, which is a default, and a service cluster local. And also don't forget to mention about service port number, which is 3000. And in terms of gateway, you need to select Ingress gateway label. So we have selector and we have a key name as Istio, and value is Ingress Gateway. And under server's condition, remember we need to define incoming port number 80, protocol to be HTTP, and host that this gateway is going to accept to be wildcard, just for this example. So we are going to deploy these two resources. So we're going to use these two commands to deploy. By the way, these YAML files are in this folder already. So if you want to take a look, gateway guestbook and also virtual service guestbook. This is basically the same thing in a README. So we're going to be copying pasting these two commands and enter. So guestbook gateway is created and virtual service for guestbook is also created. We can check them by typing kubectl get virtual service gateway and enter. So at this point, virtual service and gateway can be treated as any other Kubernetes object because these two were already created. Like concepts and objects are already created as a custom resource object. So we have guestbook virtual service and also guestbook gateway. So let's test out by sending actual traffic by using curl command. So first we want to get a public DNS name of a AWS Elastic Load Balancer, which is this one. If you're using AWS EKS though, if you're using GKE, you need to get GKEs, you need to get GCP Load Balancers DNS. And then this is the convenient command where we're gonna do curl and verbose, and we have a subshell where this is going to return this DNS name. So enter. And then this is the HTTP response in verbose. So what we are seeing here is this resolved to a public IP. So this is a DNS name resolved to public IP. This is reachable, which is great. And we are sending HTTP request to port 80 and now HTTP 1.1, and this is a response code HTTP 1.1 200 OK, and this is the HTML file. So we can access this guestbook application from Chrome as well. So remember to refresh this one. This is Istio Ingress Gateway's public DNS, and this is Nginx Ingress controller that we deployed from Helm chart. So if we copy this public DNS and head over here, basically this is the same thing. I've already opened it, enter. Now we can see guestbook through Istio Ingress Gateway. And this another tab, this one is a little bit different one. This is from Nginx Ingress controller. So either way, we can access the same application using two different load balancers, one from Nginx Ingress controller and the other one from Istio Gateway. So we have verified this one. We can also see traffic flow using Istio dashboard Kiali. So we can do that from a new tab. So Istio CTL dashboard Kiali, enter. And this is going to open Kiali dashboard. And what we are going to see is topology of microservice and also metrics, how traffic flows, latencies. Also, we can see YAML configuration as well. So admin. Remember, these are default username and password. And this is the top page overview. Default namespace, Istio system namespace, and Nginx Ingress controller. So we're gonna click these two applications in default namespace. We have guestbook and Redis. These are two. If we click on guestbook, we're gonna see overview, traffic, inbound metrics, outbound metrics. So overview, we have guestbook service. Click on that one, and here workloads, virtual service, destination rule. Click on virtual services, and here guestbook virtual service. This is the one that we deployed, and we can actually take a look at the YAML file from here in the YAML tab. And you see virtual service, guestbook virtual service, and nothing is wrong. And if there's a syntax error, then line is gonna be highlighted with red color. So right now we don't see anything, which means everything is fine. So you see status is a green check mark. So this left hand side, we have a menu. Istio config basically contains anything related to Istio resources. We have a gateway and a virtual service. These are not a native Kubernetes object. So anything to do with Istio resources, like a gateway, virtual service, destination rule, these are going to show up here. So configuration column, both of them are saying valid configuration. If there's a syntax error, this is gonna show red cross mark. So virtual service, YAML, we have already seen that one. Go back, guestbook gateway, YAML file, correct. And then the services, this is where a actual Kubernetes native services are existing. And here, guestbook Kubernetes, Redis master and slave. And the configuration shows red warning icon saying it's not valid. Sometimes this is a false positive. So overall health of the service is healthy actually. And it says selector, app, guestbook, label, app, guestbook, network, TCP 3000. And again, this is a false positive. This is the port name must follow dash suffix form. But even if this is showing warning icon, red warning icon, it does still work because we have already verified traffic going through, and we are going to refresh this page multiple times to send multiple HTTP requests through gateway, through virtual service, and then eventually to a backend pod, guestbook pod. And then go back to this graph, and then here it's gonna refresh every 10 seconds right now, and click refresh because we have sent multiple HTTP requests. Namespace is gonna be default. Version, this is okay. Display, we want to see traffic animation, so check off traffic animation. Security check off so that we can see mutual TLS icon here. Without that, we don't know if it's HTTP or HTTPS. So it's cool to see everything is HTTPS secured. Even if it says HTTP, this is just a differentiation between HTTP and TCP. And we can also show, like this is radio buttons. We can select a response time, which is going to show as latency. This is the request percentage if you have a canary. So right now, because we select the percentage, we have 100% going to only one version. And also we can do response time and we can see latency. So it says 10 milliseconds here. This is the guestbook pod, and this is connected to Redis slave database. This is Redis master, Redis slave master. So this is how you can see what is going on here. Everything is 200 HTTP 200 successful. Nothing is 4xx or 5xx. So far, we have replaced this ingress controller with Istio gateway. Okay, so everything looks good. So because we have already been using Istio gateway in a virtual service, we don't need Nginx ingress controller and also ingress resource. So this is the next section, 5.6. We are going to uninstall Nginx ingress controller, which will delete one of the two AWS EOB. So this one, bottom one was created from an Nginx ingress controller deployed by Helm chart. So let's uninstall this Helm chart. So grab this command, go down to this terminal, shell, create a shell, and then paste in this command, helm uninstall. This is a release name. We use this arbitrary release name called nginx-ingress-controller. And then don't forget to add namespace, nginx ingress controller. And now nginx ingress controller uninstalled, which is good. So if you take a look here, refresh, then one of them is gone. So now it's gonna only show only one, which is from Istio gateway service. That's good. We also have ingress YAML file, ingress resource. So if you do kubectl get ingress, we have ingress YAML. So we can delete this one as well. Also we can do is check all the resources are deleted in nginx ingress controller namespace. So let's do that. So if you do this, paste, enter, this is going to return nothing because Helm chart was uninstalled. So at this point, you can just get rid of this namespace. Okay, so at this point, we can delete this namespace. So kubectl delete namespace and copy this nginx ingress controller, enter, and then it's gonna delete the namespace. It doesn't really matter, but this is a good way to manage all the namespaces because you go to k8s dashboard and click overview. It used to have this nginx ingress controller namespace, but because I just deleted it, we only have two namespaces in this EKS cluster. So this is much cleaner than you having a lot of left namespaces, empty ones. So that's good. We can also delete ingress. So clear the shell or get ingress again. And then we have guestbook ingress. So let's delete this one. So kubectl delete ingress guestbook. Delete it. So you can check that, get ingress, and it's gone. All right. So because second load balancer is gone, this one will no longer work because the load balancer is gone. So there's only one right now, which is working, which is good. Next section, 5.7, deploy another book info sample application. So we have already deployed one sample application called guestbook. Guestbook is used for EKS cluster a demo and sample app, but this is not really suitable to be able to kind of demonstrate Istio's full features like canary release, version, subset, and destination rule. So there's a sample application catered toward demonstrating Istio. Actually, it's coming from Istio's binary folder. So if you go back to previous folder at the root, we have binary folder when we did installation. Inside this Istio, there's a folder called samples. Inside samples, there are a lot of different example applications. One of them is called a book info. So we're gonna use this book info sample application to demonstrate and enable some of the features step by step. So to do that, what we are going to do is to delete guestbook apps because we no longer need this application. This is too simplistic to demonstrate Istio. So what we're gonna do is to delete this one. So just copy this one, clear the shell, paste. Basically this command does is delete replication controller, service, virtual service gateway in English, --o. So all the pods are going to be gone. Okay, everything's done. That's good. Even deleted virtual service and gateway. So here it's gonna be empty pretty soon. Okay, good. So let's go to folder 5, export service, and show files. And we have booking for YAML, also gateway booking for YAML, and also virtual service booking for YAML. So what we are going to do is to deploy booking for pods and deployments and the services. And everything is already aggregated in this one file called booking for YAML. So that is this file, drag and drop here and show the content of this YAML file, booking for YAML. So this is going to be service account, deployment for reviews, rating, and product page. We're going to explain about components of this sample application using k8s, so don't worry about it. But for now, let's create a deployment and a service and everything. So create a shell and paste kubectl apply f booking for YAML and enter. And now here it's going to show up a lot of different pods called details. So you see here, we are creating booking for details, ratings, reviews, product page. So we have 3 different kinds of pods. Actually 1, 2, 3, 4 different kind of pods ready. And also it created services and service accounts. So once this is done, we are going to expose them using Istio gateway and virtual service. So what we are going to do is to use another gateway and a virtual service YAML file just for this booking for sample application. So drag and drop gateway booking for YAML, not the guestbook because guestbook was the previous one. Okay, and also you can drag and drop and then show content of virtual service booking for YAML, not the guestbook. So this is the content of booking for gateway, basically pretty much the same. At this point, incoming port is 80, protocol HTTP, and a host is wildcard, so accepting anything. And then virtual service wise, a little bit different. Gateway name should match with this gateway booking for gateway, and everything else host wise, this is not wildcard, but because we are using public DNS about Amazon load balancer, we are using this one. So if you are using, let's say, GKE, then the public domain name of load balancer is not gonna be Amazon AWS. So you can just do this like instead, asterisk, okay? And then HTTP, there are items under list called match. And we have multiple URI conditions here. So match is condition block. And we're saying that if HTTP request matches with this path, product page, static, login, logout, API, V1 products, then route that request to a backend destination called a product page. This is the Kubernetes service name in shorthand, or you can use a fully qualified domain name. And the port number of this service product page is 9080. So we are going to deploy these 2 custom objects, gateway and a virtual service. So copy these 2 lines and create a shell, paste, kube apply, gateway, and also virtual service, and enter. Okay, so they are deployed. You can check by kubectl get gateway, comma, virtual service, enter. And we're gonna see 2 different ones. That's good. And we can curl the book info endpoint. So what we're gonna do is to first let's say copy this part inside subshell. This is gonna print out a public DNS of AWS load balancer. So what's doing is namespace is still system, get service, service names is still ingress gateway, doing the output JSON path and the host name. Enter. This is gonna print out public DNS of load balancer in AWS. This would be different if you're using GKE. And we are wrapping this one around with a subshell and doing curl v, and then at the end we are appending /product page. So copy this one, clear the shell, paste, enter. So now this sent request to a /product page and HTML files printed out. So here first it's sending a request. This DNS got resolved to public IP at the port 80 and response code 200, which is okay. And this is the HTML file return, so which is good. You can check this one from a browser. So what you can do is to echo a entire DNS and also HTTP path. So copy this one and go here and paste in entire URL, product page, and now we're gonna see book info for the first time. So this is a book info sample, and basically this is like, oh, this is like Amazon's review kind of thing as well. So summary, Wikipedia summary, book detail, this is like a metadata book, like ISBN, language, English, publisher, page 200, and these are a book review section. And this is made up of a bunch of microservice applications. Like this component is part of our reviews, and this part is rating. Right now we don't have any ratings, but we are supposed to see stars. And this is the detail. See, this is the review. The reason why you don't see is because right now there are 3 versions of ratings, so 3 versions of reviews, V1, V2, V3, and depending on version of reviews, it's gonna show red, black, or nothing. So this is a review, and the rating is always number like a 5. It's 5, 4, 5, 4, and the details is responsible for this part. And then finally everything else, like the entire things, is provided by product page. Okay, so this is how microservice components are working together to display this one web page. So at this point, this is a screenshot. This is the same thing as this one. It's good, it's working, and we can check this one using a k8s dashboard again. So go to k8s and refresh, and we are going to see the same namespace default, but we now have 4 applications. Click this one, and we have details, product page, ratings, reviews. Let's take a look at the graph. So here we're gonna have high level overview, topology of it. So this is the how traffic is flowing. So make sure that traffic animation is checked off, security checked off, and percentage enabled, so that we can see traffic is routed to different versions. So as I explained, reviews have V1, V2, V3, and right now it's routed by a round robin, so 1 by 1. Right now nothing is flowing because we haven't sent traffic in past like 1 minute, so we can refresh multiple times. 1, 2, 3, 4. See, these are round robin load balancing algorithms, so we can see different versions 1 by 1. And here it's refreshing every 10 seconds, so refresh. Now we see traffic flow with from here is still ingress gateway, 100% go to product page, and the product page to this is a virtual service, by the way, and then from here to actual product page pod, and from pod to reviews and the details, because this needs to display detail part and also reviews part. And from here, reviews, it's almost split equally, 30%, 30%, and 30% kind of thing. So this is a round robin. And after that, everything goes to ratings except V1. Because V1 doesn't show any star rating, this is a 5 in numerical representation, this is a version 1. It doesn't even display anything because this isn't using ratings. You know, this is kind of like a progression about how you would develop an application. V1 just display nothing. V2 display rating, but in a black and white 5-star, but black. And a V3 is a colored one. So colored reviews or red one. So you can see 100%. And also if you select response time, you can see latency. So 15 milliseconds, 24 mil, 10 millisecond. Here, this part is 48 seconds. This is pretty cool. Everything is 200. Outgoing is nothing much. All right. So another cool thing you can see is go to applications. We have like 4 different ones. Workloads, this is where it gets interesting. So let's take a look at the product page. V1, health is green. Type deployment. Okay, type is deployment. Label, like app product page, version V1. Then here we have pods and service. So there's a product page service, right? And then virtual service. So let's go back. It's confusing. So product page under workloads. And what I wanted to show you is this logs tab. Under here, this is the product page V1 containers log. And this is the sidecar Istio Envoy proxies log. So it's pretty cool to see 2 containers logs in one page, as opposed to typing from here like kubectl logs and name the port. You need to copy and paste this one and then -c and name like Istio proxy. You need to do that. So here you can see this one, and side by side radio button, you can do like horizontal side by side as opposed to vertical. And inbound metrics, you can see request is coming with like a time, right? Request duration, request size, and outbound metrics. It's kind of a little cool thing. It's not too detailed one, but it can give you a kind of a high level overview. Traffic, and then service. Let's go to service and a product page. Service has virtual service. Alright, so this is a service. Circular one is service, and a triangle with a purple icon is a virtual service. So service port is 9080. Type is not port. We cannot see services YAML from here, but if you go to Istio config and select a virtual service configuration healthy green icon, click here, it has YAML tab, and inside this YAML tab you can see YAML file. Alright, action tab you can delete, but you don't want to do that, right? So this is the Istio config, and then here I have match condition displayed here, and it says port 98 is backend. So you can see this condition, product page, static, blah blah blah. You can go to gateway as well. This is a YAML file. So basically this is the gist of it. You can see different version traffic flow and also logs from workloads detail logs. So that's it for this chapter. We have successfully deployed 2 different sample applications, and we have exposed them using Istio gateway and virtual service. So essentially we have accomplished exposing application in Kubernetes cluster using Istio gateway and Istio virtual service, as opposed to traditional ingress controller and also ingress resource. Next section, we're gonna be working on traffic management part of Istio gateway. So we're gonna be digging into Istio features from next chapter. Okay, welcome back. So chapter 6, we're gonna be covering traffic management features of Istio. So remember in chapter 1, we talked about Istio service mesh architecture. We have 2 components, data plane and also control plane, which is Istio-D. So all traffic that your mesh services send and receive is proxied through Envoy, making it easy to direct and control traffic around your mesh without making any change to your application code. So this is the a diagram that we have already seen in chapter 1 or 2. Basically, this is a control plane component, a master component, which is really configuring, pushing configurations, and creating mutual TLS certificate and whatnot. And this is data plane component, where Envoy proxy is created as a sidecar container right next to application. And all the network connection among backend pods are intercepted by this Envoy proxy. So that here you can enable a lot of features like canary release or TLS, HTTPS, or authentication and authorization using Jolt and whatnot. So this is how Istio service mesh architecture was like. So to recap what data planes Envoy proxy is capable of, this is the bullet point summary of the features. So Envoy proxy is a high-performance proxy developed in C++ to mediate all inbound and outbound traffic for all the services in this service mesh. Envoy proxies are the only Istio components that interact with the data plane traffic. So there are 3 different kind of categories here: traffic control, network resiliency, and security and authentication and authorization. So in terms of traffic control, we can do different load balancing policy for backend services. Also, we can do weight-based traffic split. And this is basically the same as canary release. Also, we can do HTTP2 or gRPC proxies. In terms of network resiliency features, we can set timeouts, retries, circuit breakers, photo injections like HTTP 400 error code, or we can introduce a delay as well. In terms of security, we can do rate limiting and also TLS termination. So we have already covered about virtual services and gateways, but there are other Istio related custom resources like destination rules, which we're going to cover in this chapter, and also service entries. This is for egress for external public DNS. Without virtual service, Envoy proxy distributes traffic using round-robin load balancing policy between all service instances in the backend. This is what Kubernetes services layer 4 load balancing can do for you by default. But with virtual service and also destination rule, we can configure custom load balancing policies for backend pods using like round-robin, random, or least connection. Destination we're going to cover a lot later. Service entry, this is the if the destination host is outside of Istio service mesh, for example like AWS RDS, or it could be like on-prem but static public IP or host, then no mesh service needs to be added using the service entry custom resource object. This is already explained in chapter 2, I believe. And in terms of traffic, this is already explained at the top. Alright, so section 6.1, we're gonna be covering traffic splitting or canali or weight-based routing using virtual service subset. So take a look at this diagram here. We have seen this kind of diagram already. This is a linear view. In on a gateway from outside, this is the VPC boundary, and an internet gateway here, and a load balancer. And then behind the load balancer is Istio Ingress Gateway service. And behind that is Istio Ingress Gateway. Inside this pod, there's a standalone Envoy proxy running inside, in which does layer 7 load balancing based on this virtual service YAML file. And remember, virtual service YAML file was kind of a replacement for ingress resource YAML file, which define HTTP block, where we can define backend services and also pod. So we talked about how gateway and a virtual service needs to be deployed together. They come hand in hand. And what's interesting about this traffic splitting is what comes after virtual service. So in this diagram, there's a new custom resource called destination rule here. So destination rule YAML file is this one. I've already explained briefly about features of these in chapter 1 when we are doing introduction to Istio. Basically, this chapter is about the nitty-gritty details of these features. And here is a destination rule custom resource YAML file, and we have subsets, and we define version v1 and version v2. These are labels to the attached to the pod. And what's interesting is the virtual service can define subset v1 and a subset v2 with weighted number like 10% and 90%. So that's why in this diagram it says 10% of traffic goes to destination rule subset review v1, and then 90% goes to review v2. And all the traffic goes through a review service, but from here 10% goes to pod with a label version v1, and then 90% goes to pod with label version v2. So this is what's possible with traffic splitting or canali or weight-based routing, right? So what's cool about Istio is that inside this Kubernetes cluster, so inside this one, you can even customize a little bit fine-grained details about how to control and manage traffic. Without Istio, if you're using just ingress, everything goes to round robin, so everything's equally routed and load balanced. So this is one of the many features that Istio offers, and one of the first things that we are going to cover here. Alright, so to enable traffic splitting, there's a few steps. So step 1, we need to add version label to pods. Basically, in this diagram, there are two red circles here. So here, labels are two pods. You take a look, labels app review in version v1, app reviews in version v2. We need to add labels like a version label first, and this is already done by book info. So let's check pod labels for pod with app reviews. So with this label app reviews, it's gonna pick up all the reviews pod because they are common denominator. So we are going to copy this command and paste in here. Basically kubectl get pod -- show labels, and we are filtering pods by providing selector argument with app reviews value and enter. And this is going to return 3 pods: review v1, v2, v3. And because of this -- show labels argument, we are seeing all the labels. So all of them have app reviews, And also they have version v1, version v2, and version v3. This is already done by Istio provided this book info sample applications YAML file. So we don't really need to do this one. But if you're creating a custom application and deploying, you need to add this version v1 or version v2, or it could be version 1 or version 2. You just need to use a version key name. So this is the output. We have seen that. And notice 3 different reviews pods have version v1, v2, v3. These pods are created from 3 separate deployments. So we can display deployment actually. So kubectl get deploy and then selector app reviews. And we're going to see 3 different deployments, v1, v2, v3. v1 is going to create this pod. v2 is going to create this one. And you can also see this on k8s dashboard. So we already have k8s open. So let's take a look here. Workloads. And we have 3 reviews, v1, v2, v3. Type is deployment. And type is deployment. And also we can see important labels, app reviews, and version v1, v2, v3. However, they are proxied by one service using app reviews label. So if you display label of review service, which it's gonna be here, one of these, a service detail, product page, rating, let's expand this shell, service review, let's show labels attached to this one. So kubectl get service reviews show labels. Okay, kubectl enter. Okay, so it has label, app review, service reviews. And because app reviews are attached to these 3 deployments, so this is going to be common denominator, and that's the reason why it can do load balancing among these 3 different pods created by 3 different deployments. So this is what we did here. And you can also see that from a k8s dashboard as well. So click services, we're going to see reviews here, this one. And then we see labels here, app reviews, service reviews. So far, so good. And in step 2, we are going to create Istio destination rule resource. This is the first time we are dealing with. So basically this component, this is the simplified version. It's not the fully correct one, but we have this YAML file in the folder already under 6. So let's take a look at the folder. So the name would be destination rule version. So let's see, destination rules versioning. All right, so this is the destination rule. Metadata reviews, host reviews, subset, and here is a list of names, v1, v2, v3, and under this name, there's another map called labels, and a version v1, version v2. So this version v1 needs to be matched with label attached to pod definition. In terms of a host, this is a Kubernetes service name, reviews. And here a subset version of a route destination is identified with a reference to a named service subset, which must be declared in corresponding destination rule. So what I mean by that, subset and a version, pretty much this is a synonym. A version of route destination, which is a v1, v2, v3, is identified with a reference to a named service subset, which is this one. So v1, v2, v3, these are subset name v1, v2, v3, must be declared in this destination rule file, which is this one, all right? And this is a little bit of a quick destination rule anatomy, okay? So we have traffic policy, load balancer. This is omitted here because this is by default. So you don't really need to specify this explicitly. But if you want to customize load balancing rules, then you can do so here. Change this round robin to, let's say, random or least connection. As I've already explained at the beginning of this chapter, you can customize load balancing policy. And then here, subset section, you can have name of subset, v1, v2, v3, or it could be, let's say, version 1, version 2, or it could be staging production. You can customize this name. However, this is the actual label attached to pod. So this needs to be exactly the same one as the pod's label. Whereas this one is just a name. It could be like alias, okay? All right, that is a breakdown. And traffic policy, this can be load balancing policy, round robin, random, least connection. Also, you can have 2 more different configurations, connection pool size and outlier detection. This one we're gonna cover a lot more in the coming sections in this chapter. Basically, these are rate limiting and also circuit breaker. And we have subset here, 1 or more named sets that represent individual versions of a service. So this one, So this one represents one version, this one represents v2, and this one represents v3. We are going to apply this destination rules. So go to this terminal, clear the shell, go back to previous folder, and then go to folder 6 traffic management ls, and you can see a lot of files, but don't worry. So we are going to copy this command, kubectl apply-f destination rules versioning, enter, and destination rule created. You can check this one by kubectl get destination rule. dr is a short name, and then we have the views. That's good. And if you go to k8s dashboard, click Istio config because destination rule is not native Kubernetes object. This is Istio related custom object. Now we see destination rule reviews. Click this one and you can see YAML. This is exact the same content of destination rule as the file that we were just looking at. Reviews, subset v1, v2, v3, and some metadata were added, so you don't need to worry about these. But anyways, cancel. And then we have subset, we have different representation here. It used to be YAML file representation here, but right now we have a table representation. Name v1, v2, v3, and then labels version 1, v2, v3. So this is a cool visualization. Host is reviews. Reviews jumps to reviews service, which is good. Alright, so reviews looks good, created at this date. Alright, so that's all. So step 3, add subset and wait to route destination in virtual service. So take a look at this diagram. In this step 3, we're gonna be configuring this part, virtual service. We have already created a destination rule YAML file in step 2, and we have already attached pod label in step 1. So this is the last step for Canary release. So inside this virtual service YAML file, we need to add subset and also wait. So we have a YAML file already provided. This is basically the content. In the folder, it's gonna be virtual service reviews Canary. So virtual service reviews Canary. Drag and drop. This is a name, virtual service reviews Canary. And basically, let's do a little bit of an overview. We have host destinations that these routing rules apply to. So we are going to limit name host to be just reviews. As with any virtual service configurations, we need to select the gateways. We are selecting Bookinfo Gateway and also mesh. This is first time. So if we select the Bookinfo Gateway, then these rules are going to be applied at Envoy proxy at the edge of service mesh. This is the gateway. Gateway is sitting at the edge of service mesh, and this mesh is the one that's inside. This is a sidecar Envoy proxy. So you have two options to really select here. If you only select Bookinfo Gateway, it's gonna be applying these rules to edge Envoy proxy. Whereas mesh one, this is gonna be at all the sidecar Envoy proxies, meaning that this traffic rules are going to be applied for all the connections among pods. Whereas this one is going to be about when the traffic is coming in through the load balancer. So I have a little bit of comment here. Don't only use this gateway, as reviews Kubernetes service is used internally by product page service. So this virtual service rule should be applied to Envoy sidecar proxy inside the reviews pod, not edge proxy in gateway pod. What I mean by that, this is a little bit confusing. So let's take a look at the graph here. See, this is a product page, and the reviews is not really publicly exposed, right? When they use, okay, let's show Istio system as well, so you can see ingress gateway as well. Okay, so traffic is flowing from ingress gateway. This is the edge proxy, standalone edge proxy. This is what this gives you. Bookinfo Gateway is sitting here basically, but review service is not exposed at this point. I mean, first hop is product page, and the product page is actually using this internal service called reviews, right? And we have v1, v2, v3. What we want with this weight 10%, 10%, 80% or something like that, we want traffic rules applied at this area, product page reviews. So inside this product page pod, which you can see in product page pod, 2 out of 2. So there's a sidecar Envoy proxy. We want this HP routing rules to be applied at sidecar container here, so that traffic going from here to another sidecar Envoy proxy inside this reviews, right? 2 out of 2 is a sidecar. So we want this to be applied for sidecar, and that's the reason why we need to select dash mesh. So there's a comment applies to all the sidecars in the mesh. The reserved word mesh is used to imply all the sidecars in a mesh. When gateway field is omitted, the default gateway mesh will be used, which would apply the rule to all the sidecar in a mesh. If a list of gateway name is provided, the rules will be applied only to the gateways. However, to apply all the rules to both gateways and sidecars, specify mesh as one of the gateway names. So if you don't provide gateway condition here, if you just omit entire highlighted area, then it'll default to a service mesh entire sidecar proxy. However, if you only specify gateway, this rule is going to apply only to this area, is your gateway. But because this reviews is not publicly, like it's not the first hop, it's internal one. If you do booking for gateway, then you cannot do canary release. I encountered some weird behavior. Somehow traffic wasn't canary routed, and this was the reason I needed to add dash mesh. So it took me a little bit, probably 30-45 minutes for debugging. The reason why traffic wasn't split by weight, the reason why I didn't add mesh, so that the traffic rule needs to be applied at this area, not just here. This is pretty important stuff. Anyways, so let's apply. So we're gonna copy this command, apply virtual service reviews canary, paste and enter. Alright, so virtual service created. So it's actually virtual service. kubectl get virtual service to validate, and we have reviews. And we can go to Chiari. This is one of the other things that's cool about Chiari. We can check configurations. So inside here, we don't need to specify Istio system because it's going to show too much noise. We have reviews, virtual service, and also destination rule. Destination rule we've already created. This is step 3, virtual service. And here we have table representation of v1, v2, v3. This is created by destination rule in step 2, but in virtual service we specified weight 10 10 8, right? Here we specified 10 10 80 for v1, v2, v3, and that's why we see this one. And this is another diagonal representation, 10%, 10%, 80%. This is good, and this is a YAML file, very convenient. 80, 10, all good so far. And then gateways, this is basically YAML files. This component, gateways, booking for gateway, and a mesh. So there are 2 components, host, reviews. So you can see everything in Chiari. Alright, so this is the last step. Step 4, test and verify canary traffic splitting. So we can copy this one and just print out an entire URL that we need to hit. So basically we need to check this one from a browser, from here. Basically it's the same thing. Product page, refresh, refresh, refresh. And right now it used to be 33%. It was like even round robin. But now because we added 10%, 10%, 80%, the traffic percentage is gonna be different. To really verify traffic is really split according to this weight, we are going to send 20 requests. I've already provided this convenient bash command for loop from 1 to 20 do curl. Basically send 20 requests to the same endpoint in a batch. And after that, at that point, if we have 20 requests, traffic percentage is gonna be converging to 10 10 80, hopefully. So let's say this is gonna finish 20 requests. It's gonna be roughly about 10 10 80%. So that's a Chiari dashboard graph. Select default namespace and display drop down and check for traffic animation. And make sure to check request percentage radio button. And then here you're gonna see dashboard will show request percentage v1, v2, v3 roughly 10 10 80. It's at 15 6 81. So 20 requests are sent. Let's go to dashboard, hit refresh button, and then click on this display radio drop down, select request percentage, not the response time. So we see 88%, 11%, v1 is not being used at all. Alright, anyways, 80%, 82%, there should be a traffic to v1 as well. Alright, so we can do one more time. But eventually this is how you can verify. This is a really cool thing about using dashboard, that you can know how much a percentage of traffic are being routed to which version of backend service. See now 25, 25, 50. So 1, 1, 2 in terms of ratio. And this is going to be different over time, but this is going to converge to the definition of virtual service. See, it's a 16, 16, 66. You get the point. It used to be 30%, 30%, 30% because we didn't have a virtual service. We only had a Kubernetes service by default, which was doing round robin. So it's about 10, 30, 60. But anyways, if you go from browser, if you refresh, remember when we were refreshing first time, it was alternating between V1, V2, V3. But this time, you're going to see a lot about red color one, which was V3. V3 was 3 times in a row, 4 times in a row, 5 times in a row, 6 times. And then this is V1, which is good. Another one, 7. And this is another V1. It's about right. All right. So that's good. So we just verified that canary release works. 5, 20, 73%. That's good. All right. And another thing is that you can see request tracing metrics from service reviews traces. So let's take a look. Services, and we go to reviews and traces. You see a whole bunch of traffic were centered around this time. This is the local time here, and all of these traces. And if you click this one, it's gonna show traces. So 8 spans, default, details, Ingress gateway, product page, rating. You click this one, you see details, expand, and you see this is a really cool thing. The HTTP request content probably, yes. Tags, process tag, default, and ratings, expand. All right, so this is the Kiali, and this is the so this is how you can configure and test canary release, like weighted average routing. So section 6.2, we're gonna do identity-based routing. So as we have already seen this diagram in chapter 1, based on HTTP header's value, in this case in this diagram, end user tester. And if this user is sending a HTTP request, then virtual service has already configured that if end user is tester, then request should be routed to backend reviewed service for version or subset v1. So this red arrow represents traffic flow from user tester through internet gateway, load balancer, Istio ingress gateway service, pod, and a virtual service, which is where we define a match condition to route traffic from end user tester to backend reviews v1. So requests go through virtual service and then go to destination rule subset reviews v1, and then goes to reviewed service, and then eventually get routed to pod reviews v1. So as with last section, we already have YAML file prepared. So you just need to open up this YAML file called virtual service reviews header condition identity based. So virtual service reviews and header condition identity based YAML file. So this YAML file already contains match condition for end user logging as this user. I wanted to make this value a little bit more meaningful so that you know that you need to use this value to log into your booking for web page. And then if HTTP header request contains end user with this value, then request should be routed to reviews v1. Everything else is going to be routed to v1, v2, v3 using a previous section's canary release, so 10, 10, 80%. And also there's one note here. This is a commented out section. It says don't do this as rules are evaluated in order. So if you have match condition here at the bottom, then this will never be evaluated because it's going to be evaluated from top to bottom. So don't do this one. This is an anti-pattern. So with this YAML file, what we are going to do is to just apply. So kubectl apply if virtual service reviews header condition YAML file. All right, so let's do this. Let's go down, copy this command, then enter. Okay, so YAML file doesn't exist. So let's take a look here. ls virtual service reviews header condition, virtual service review header condition, identity based. Okay, so what we're going to do is to copy this command and paste, enter. This will create another virtual service reviews. How to test? there's a little bit of a warning here because when I was testing, it didn't work for the first time, and it took me a few hours to debug why this wasn't working. So basically, passing custom header attributes using browser plugin or curl wouldn't work because product page app won't propagate these header attributes to backend reviews app. Usually this should work, but with a Bookinfo sample application, this doesn't work. So if you want to pass this header attributes end user, you need to log into a Bookinfo webpage using this sign in button, right? So won't work section if you are using browser plugin. In this case, I was trying to do it. I was passing user agent or end user or some other attribute. It didn't work because this wasn't propagated to a reviews application. I opened up a Chrome developer tool and I see the header request contained this attribute that I set from using a browser plugin, but still product page service and app didn't pass this one to the reviews app. So obviously curl didn't work either. Curl with -- header, user agent or end user, tester, or whatever the values you define in the YAML file, it didn't work either. So I figured this is unique to Bookinfo application, and I realized looking on Google, going through Stack Overflow, that Bookinfo's product page doesn't propagate header attributes backend. So only way to do this in this case is to log into Bookinfo page as a user. So at the top right corner, there was a sign in button. So what we're going to do is sign in and using the value you define in the YAML file, in this case, login as this user. Then you should be able to see a reviews v1 being rendered here. Remember, reviews v1 didn't show any reviews. So that's what we are going to do. And this is the k8s diagram. So you see a request was routed through product page and then reviews virtual service and eventually reviews v1. That request was only routed to v1 if your username was logging as this user. So let's do that. So from a Bookinfo page, which is this one, refresh first, and then it works still. Okay, so click sign in. Username is from YAML file, login as user. That's it. You don't need a password, just need to use this username, and this will be created, and then you sign in as a login user. Now you see review v1. You refresh multiple times, you're gonna only see reviews v1. So you can see k8s dashboard again and then see traffic flow from here. This is the old one, it's expired, so I needed to open another k8s from a shell terminal. And then this is the new one. Okay, so go to graph, select default and display, request percentage traffic animation, and then you see already a green mark goes to reviews and reviews to reviews v1. This is because of a new configuration. So if you go to Istio config and take a look at the reviews virtual service, then now you see match condition headers end user needs to be exactly as login as this user. This is the username. And then if so, then the request is going to be routed to v1. And that's the reason why we saw that in this graph, right? So everything is working fine. So that's all about 6.2 identity-based or HTTP header. Next, section 6.3, we're gonna do query string condition routing. So just like a header attribute-based routing, we're gonna be configuring virtual service to route based on query string. Query string is value appended after slash with question mark and a key equal value. So in this case, query string value is test v2 equal true. So if test v2 is equal to true in this virtual service, we want the request to be routed to reviews v2, which is this one. So this pink arrow represents traffic flow from a user to the backend port review v2 based on virtual service configuration like this one. All right. So in this case, we're gonna use another match condition, but key value of the map is gonna be query parameters, query params. And then key name is going to be test v2, the value will be true. So the YAML file is virtual service reviews header condition query string. Just take a note here, and this is going to be a little bit different from previous section. Previously, the name was headers as opposed to query parameters. So now we have match query params. This is the key name, this is value. Then just route to a backend, whatever the subsets we want to define. So letse do that. So we're gonna do kubectl apply -f virtual service reviews, and from here we have header conditions and then query string YAML, and then enter, and then it worked. So now go to Kiali, click istio-config, and then click reviews virtual service, and then make sure that configuration is correct. Second match condition. So this is a list of a match condition, and then here is another list, match query params test v2 true. Okay, and if so, then route traffic to subset v2. So we have two match conditions. First one is a header, second one is a query params. Unfortunately, product page app won't pass along this header info as well as query string parameters to the views app, so we cannot test this one for the views service. So if we add this match condition, not for the views, but if we do this for product page, this will work. But we only have one version for product page, as you can see in the topology diagram, only one, v1. So if we want to pass query parameters from product page to reviews, then we need to change application called a product page, but we cannot do that. So unfortunately, for this booking for sample application, we cannot really test query string condition. But here using normal application, then you can configure, write your code to pass along HTTP header request information to backend services. Right now, product page doesn't propagate query parameters or header attributes in a request, so you cannot do this for reviews. Alright, so moving on to the next section, 6.4, URI or HTTP path conditional routing. So take a look at this diagram again. So virtual service right now has match condition with list of URI with regex key and then product page / v2. If so, if HTTP path is product page / v2, then we want the request to be routed to reviews v2. So this is pretty simple. It's kind of similar to query parameters. So we have, instead of query parameters in last section, we have a URI, and here it could be exact, or it could be prefix, or it could be regex. And then we specify product page v2 for just for this example. It could be any customer arbitrary value here. And also you can add attributes like ignore URI case. This is like ignoring case sensitivity. And in this case, set it to true. And then if URI condition or HTTP path condition is matched, and then route request to reviews v2. It's very simple. It's very similar. However, as with the previous sections, product page doesn't pass along header info including HTTP path, so we can already test this one with reviews. So we're gonna just move on. Okay, so next section, 6.5. Inject latency delay for resilience testing using virtual service. Take a look at this diagram. We've already seen this one in chapter 1. But basically, this virtual service configures fault, delay, percentage, 100% request, and then fixed delay to be 10 seconds. So what's going to happen with the request is that the black arrow represents the traffic flow from outside to VPC to a load balancer to gateway service pod in a virtual service. And then from here, because of this virtual service configuration, 10 seconds of delay is added. So what's going to happen is the virtual service is going to return any response from the backend 10 seconds after. So it's basically adding 10 seconds latency to the response. This is kind of an interesting way to test how other microservices behave based on other dependent microservice applications. Because in a real world microservice architecture, there could be 10 or 50 microservices relying on each other, right? So we don't want one failure of a microservice to affect other microservices. So that's the reason why we do test by adding some delay. For example, this review service is dependent on rating service. In the product page, it's dependent on review service. So by adding delay 10 seconds to reviews response, we can test how product page performs and behaves with slow microservice. So to do this one, we have a YAML file already provided. So it will be virtual service rating fault injection delay YAML file. So most of the stuff remain the same except that fault block. So we still keep match condition with a header and the user tester. This is a good practice probably because we don't want to inject a delay of 10 seconds to all the requests from clients. We want to inject some delays only if user is tester, right? So in that way we can ship some traffic only for this test user. And then fault section defines delay and a percentage of traffic we want to inject a delay, in this case 100%, it should be a double, 0.0 to 100%. This is a range of a value, and then fixed delay. In this case, we specify 10 seconds. And then under the match condition, everything should go to V1. And then this is the global running condition. All right, so let's apply this virtual service. So scroll down and then copy this command. Virtual service rating fault injection delay YAML. Paste, enter. All right, so virtual service is configured. Let's check that from Kiali, istio config, and then we have configured ratings, right? So go to ratings, virtual service, click this one, and then click YAML tab. And then now we should see match header, and also we have fault delay 100% for 10 seconds. So this is correct, so that's good. So how do we test this one? First, we need to log in as a tester because this delay is injected only if header contains end user tester. So we need to do this to log into a booking for dashboard as a user. So let's do that first. First, log out from a login as this user, and then log back in as this time tester. Sign in. You don't need a password. All right. So now we are logged in. Refresh. 1, 2, 3, 4, 5. Refresh again. 1, 2, 3, 4, 5. About 5 seconds delay right now. So you expect the booking for homepage to load without errors in approximately 7 to 10 seconds. However, the review section displays an error message. Sorry, product reviews are currently unavailable for this book. We've seen that from rating services currently unavailable. This was a result of a product page receiving a timeout error from the review service, which couldn't get a response from a rating service, which has 10 seconds delay within product page timeout. So what's happening is that there are 3 microservices, and then the traffic flow happens from product page to reviews to ratings. We know that from Kiali's dashboard. So go to Kiali graph. We have on the left hand side is product page, and the middle one is reviews, and then eventually we have ratings. So ratings are last service. So review is the last service. So in this order, product page, but product page has 3 seconds timeout and 1 retry, so maximum 6 seconds. So this is already configured in product page application code. So we have no control over this one. This is application level timeout and retry. And after that goes to reviews, ratings, but before waiting for 10 seconds, upstream service product page has already max 6 seconds to wait, and after that it'll return something. And that's the reason why we see ratings unavailable, this message, because product page, which was upstream or the core stack, couldn't wait for more than 6 seconds, like 3 seconds timeout and retry. And therefore, this 10 seconds really didn't affect product page because this was shorter than this 10 seconds delay that we introduced. All right, so we've seen this one from book info. You can also check this delay from developer tools menu. So this is from a Chrome. So right click this one, click inspect, and then it's gonna see tab here. Click on network tab here, and then refresh again. Refresh the page, and then we see product page here, right? And we have about 1000 milliseconds. So it's about 10 seconds, right? It says that response is 200 OK. It's because product page itself returned even if reviews and ratings didn't return, right? So this is the latency you can see here. Product page about, all right, do it one more time. It's taking a long time. This time 3 seconds, and this time 3 seconds as well. The reason why this is not like 6-7 seconds is because Google is already caching some of the contents. All right, but usually if you access this book info page first time after logging in as a test user, you're gonna see 6 to 7 seconds delay. So you're gonna see this in the Kiali dashboard as well. So go to Kiali and refresh, and you should be able to see this time. Click this drop down display and then show request, not request, but response time. We want to see latency. So you see here, it's 5 seconds here and also 5 seconds here. This is taking a long time. And then from here to here is taking forever, like 10 seconds. So let's try that again. Refresh, refresh. And then from here, refresh again. Request should reach ratings. And then from here, there's a 10 seconds delay, right? It's very slow. 5 seconds here, 5 seconds here. All right, so in this diagram, you see 9 seconds delay and a 5 seconds delay. But anyways, I want to explain why 7-second latency despite 10 seconds delay. I've already explained this one, but timeout between the reviews and ratings service is hard-coded at 10 seconds. However, there's also hard-coded timeout between product page and the review service, coded as 3 seconds plus 1 retry, so a total of 6 seconds. As a result, the product page code to reviews timeout prematurely and it throws an error after 6 seconds. So this is the reason why we don't see 10 seconds of a delay. Alright, anyways, so this is how you can inject some delays intentionally to see how other microservices behave. So this time, virtual service configures a fixed delay 10 seconds, but also we're gonna have timeout for 1 second. So what's gonna happen is that this black arrow and then goes to red arrow with 10-second delay. This was already configured in a previous section. We're gonna be introducing 1 second timeout. So even if 10-second delay is introduced, after 1 second of not getting response, virtual service is gonna say, okay, this is enough. After 1 second, it's gonna return error code. So this is what this section is about. Alright, so let's read out here. A timeout is the amount of time that Envoy proxy should wait for replies from a given service, ensuring that services don't hang around waiting for replies indefinitely, and codes succeed or fail within a predictable time frame. The default timeout for HTTP request is 15 seconds, which means that if the service doesn't respond within 15 seconds, the call fails. But we can customize and then say, instead of 15 seconds, we can do 1 second timeout. It still lets you easily adjust timeouts dynamically on a per service basis using virtual services without having to edit your service code or application code. Here's a YAML file, virtual service ratings timeout YAML. What's notable here is that everything else is pretty much the same. We have match condition for header, end user is exactly the same as tester, then we want to introduce a fault of delay of 10 seconds, and also they should be routed to version 1. What's newly introduced here is at the top, just under HTTP block, we have a timeout 1 second. Default timeout for HTTP is already 15 seconds. I've already mentioned that, and we have a custom timeout for 1 second. So basically, this timeout 1 second is gonna be overtaking this fixed delay of 10 seconds. This is gonna have a much more higher precedence over 10 seconds. Let's try this one. So first, we are going to apply the kubectl apply command. So let's grab this command first. So which is here. So grab this command, copy, and in shell, paste in, enter. And then next, visit the endpoint from a browser. The reason that the response takes 2 seconds now, even though the istio timeout is configured at 1 second, is because there's a hard-coded retry in a product page service, so it codes the timing out review service twice before returning. Also, product page application level timeout is hard-coded as 3 seconds, so if you try to override this value, it needs to be less than 3 seconds. Otherwise, if it's more than 3 seconds, stricter up-level timeout will take precedence, just for this booking for application only though. So even if we change timeout to 10 seconds, hypothetically speaking, up-level timeout is 3 seconds, which is shorter, so this is gonna take precedence. So this wouldn't work just for booking for application. But anyways, we applied. So let's go to a browser, Bookinfo, refresh. We are already logged in as a tester, which should be okay because we have defined in a YAML file that end user tester, yes, it's gonna be having 10 seconds delay, but with a timeout 1 second. Let's refresh this one more time. 1, 2, 3. About 2-3 seconds, right? 1, 2, 3 seconds. Right, so we're gonna copy this command and okay, so we're gonna copy this command and paste in the terminal and enter. Okay, and a virtual service should be configured. So go to isseconfig and kiali, and we configured the reviews service, right? Reviews. So click on this reviews virtual service, which is this one. Click YAML tab, and we should see timeout 1 second. Timeout 1 second configured. All right. So let's go to the Bookinfo page, logged in as a tester, refresh. Now it should take about 2 to 3 seconds. One more time, see 2 seconds, 2 seconds, and then 2 seconds. So previously it was about 7 seconds, but because we introduced timeout to 1 second, because we have product page application level retry to be 1, so it will retry one more time with a timeout to 1 second. So 1 second, 1 second, and total about 2 seconds. So now you see here, it's about 2 seconds, 2.4 seconds retry, and then it will return error code. All right. So now reviews, sorry, product reviews are currently unavailable because the reviews are timing out. This is what's expected right now. All right, that's good. Okay, so next section, 6.8. We are going to configure retry for resilience testing using virtual service. So we have already configured 10 seconds delay and a 1 second timeout. What we are going to add here is retries. So these three red arrows. So basically, if this 10 seconds didn't work, then we should retry maximum 3 times. This is configurable here. Retries attempt 3. So this is an arbitrary value. Attempts 3, it could be 2 or 1. And then each retry, we can configure per try timeout. It could be 3 seconds, it could be 5 seconds. So in this case, it will do 3 seconds timeout per 1 retry times 3. So the following example configures maximum 3 retries to connect to this service subset. So the following example configures a maximum 3 retries to connect to this service subset after initial call failure with 2-second timeout. So in this case, 3 seconds. So each with 3-second timeout. Okay, so what we have introduced here is under HTTP, we have retries, attempt 3, default is 1, per try timeout is 3 seconds, and a retry on following these conditions like 5xx from a backend service, gateway error, reset, connection failure, refuse stream, and whatnot. Entire details of what you can retry on can be found on Envoy Proxy documentation page here. And everything else is gonna be the same. So merge condition, if a header contains end user tester, then we're gonna introduce this time 15 seconds delay, which doesn't really matter. It could be 10 seconds or 15 seconds. And then we send a request to version 1 of ratings. All right, so even if we define the retry 3 seconds timeout per retry and a maximum 3 retries, which means 3 seconds of timeout plus first request, and the first request fails, so therefore we're gonna do 3 more retries. So total 4 requests times 3 seconds is 3 times 4, 12 seconds total. Because of upstream product page's application level default timeout of 3 seconds with 1 second, which is total 6 seconds, after 6 seconds, product page will get timeout error from reviewed service before getting response from ratings. So even if we configure this one, top level product page is gonna time out and return in 6 seconds. So no matter how long it'll take in the downstream, upstream in a core stack, which is a product page, is gonna set the boundary to be 6 seconds. So we can apply this one and test this out, but eventually product page is gonna return in 6 seconds anyways. Okay, so we're gonna skip this one. Next, 6.9. Mirror live traffic using virtual service. This is the first of its kind. So in a virtual service, we define mirror section, basically has mirror percentage to be 100%. This blue arrow represents live traffic to version 2, right? So based on this route configuration, this is a global configuration. 100% of traffic should be routed to reviews v2, which is this one. And then this mirror section is basically saying 100% of live traffic to v2 should be copied or mirrored to a subset v1. So this red arrow represents a mirrored version of live traffic. So in this way, when you are, let's say, introducing a new application version, you can deploy a new application version, but you don't want to send live traffic to a new one because you don't know if that works yet. So you want to test that out with a live traffic. In that case, you can send some live traffic to a new version by mirroring it, and it wouldn't return response to a client. It'll just send a request and that's it. It won't do anything with the response. Mirroring sends a copy of live traffic to a mirrored service, and when traffic gets mirrored, the requests are sent to the mirrored service with their host authority headers appended with dash shadow. For example, cluster-1, if that is named the host, it'll become cluster1-shadow. All right, so this is the YAML file, virtual service reviews mirror.yaml. So we have HTTP block and we have a mirror block. And this is a global configuration. It says reviews v3 for 100% of requests. And we have a mirror block, 100% request to v3. This is the global one. So 100% of v3 should be mirrored to v1 of reviews. So let's apply this one. So grab this command, kubectl apply virtual service ratings first, and then after that, grab virtual service reviews mirror. Okay, reviews configured. So let's check first from k8s config. So Istio config and then reviews virtual service. Click YAML tab, reviews. There's a mirror block here, 100% of traffic to the v3 is going to be mirrored to v1, which is correct. Also, go back here, Istio config, and then we want to see virtual service of ratings. Click YAML, and we have ratings, match condition if tester, go to v1, everything else v1. Nothing significant here. Destination rule is saying red icon with a warning. Not all checks passed. So something is wrong, and it's okay. So it says that the subset labels are not found in any matching host. Basically, it's saying that ratings pod where these labels don't exist. There's only one rating pod deployed, which is only v1. So v2, v3 not found. That was error, which is okay still. This is gonna still work okay. So what we are going to do is visit the URL from the browser first, refresh, and nothing should happen. Now everything's working because we got rid of a delay, timeout, and retries. And then if you go to workloads menu and then go to inbound metrics, notice that all the traffic goes to reviews 3. Everything's red. It's because of the reviews YAML file. So live traffic 100% goes to reviews version 3. Alright, so go to workloads, reviews v3, and then go to inbound metrics, and you see requests coming in here, right? That's okay. This is expected. What's interesting is that v2 shouldn't see any inbound metrics because v2 is not receiving it, right? That is correct as well. But v1 is going to see some incoming metrics because traffic is mirrored. So what's going to v3 are 100% mirrored to v1 because of the YAML configuration. And that's why we saw what we saw. So v3 should be receiving traffic, which is fine, right? And what's interesting is that here, you can go back to the README as well. As you can see, v3 should see incoming, v1 as well because of mirroring traffic. And if you go to v1's Istio proxy logs, you're gonna see that header host is appended with dash shadow, as in reviews dash shadow. So let's go to reviews logs under reviews v3, and this is the Istio proxy log. So you're gonna see HTTP header request here, and host will be reviews, right? Reviews, port 9080. This is the destination, reviews default. That's expected. But what's interesting is if you go to reviews v1, go to logs, here you don't see anything. But from here, Istio proxies log, you're gonna see reviews dash shadow. Remember here? Reviews dash shadow. So this verifies that this request was shadowed from v3 to v1. However, if you go to v2, you don't see anything. As you already saw, v2's inbound metrics doesn't show anything. Logs doesn't show anything. This is correct. This is expected. So this is how you can enable mirroring traffic and how to test this one. Next, we can configure load balancing policy using destination rule. So remember in chapter 1, I mentioned that how we can customize load balancing policy without Istio. By default, if you're using Kubernetes YAML, if you're using Kubernetes service does layer 4 load balancing using round robin. But we can customize it using either least connection or random or round robin. So in this destination YAML file, we have subsets v1, and then under v1, we have traffic policy. We can add this custom traffic policy here. Says simple least connection. So for v1, which is these two parts, we want to use least connection load balancing rule. However, we also have a traffic policy at the top, not underneath subsets, but top. So this is a global load balancing policy for review service. So this is a global one, and this is a version specific traffic policy. Version specific one, and also service level global one. In a global one, load balancer simple, round robin. So anything other than v1, let's say v2, v4, v5, are gonna be using this global round robin. But just v1, we have least connection load balancing rule. So destination rule defines policies that apply to traffic intended for a service after writing has occurred. So what this means that request is coming from the internet and then goes through internet gateway load balancer and a gateway service pod and a virtual service. And remember in a virtual service YAML file, we define layer 7 load balancing policies. We define backend service, backend pod, and a lot of different stuff we can define. And then here, we define where to route traffic to, meaning like we associated backend service name in virtual service in the route destination block. And after that, so this is what this means. Apply to traffic intended for a service after routing has occurred. So routing has already occurred to reviews. And this is where destination rule comes in. So destination rule is kind of like adding a little bit more flavor after routing occurred. So at this point, the request knows where to go. And then here we are adding some little additional flavor called the destination rule with some like, let's say, load balancing policies. So this doesn't really include routing location. We already know that this traffic goes to reviews because of virtual service configuration. But with the destination rule, we can customize how requests are going to be load balanced. So this is what it means. Destination rule defines policies that apply to traffic after routing has occurred. And here is a summary. Destination rule can configure load balancing algorithm, random least connection round robin. This is the default. Also, connection pool size from sidecar. This is exactly the same as rate limiting. We're going to cover later. Also, outlier detection settings to detect and evict unhealthy hosts from a load balancing pool. This is going to be about a circuit breaker. We're going to deal with this one at the last section in this chapter, circuit breaker. So, without Istio's destination rules traffic policy, by default, you are left with the Kubernetes services layer for load balancing, which is a round robin by default. With Istio's destination rule, you could control and split traffic to subset version pods, and among those pods, you can configure fine-grained load balancing algorithm, such as round robin, random least connection, and also you can configure sticky session as well. We're going to cover this in the coming section. So this is the round robin load balancing example. Because this is the default, you don't need to really specify traffic policy, and therefore I comment these sections out. So with the destination rule, spec host, reviews, this is a name the service, and you don't need anything. But if you want to customize, then let's say in case you want to do random load balancing, then this algorithm says that it'll select a random healthy host. The random load balancer generally performs better than round robin if no health checking policy is configured. And then this is here. So under host, you can add a traffic policy, load balancer, simple is a key name, and the value is random. If you want to do least connection, then you just swap it to least connection. This is big O1, so which means constant time algorithm, which selects two random healthy hosts and picks the host which has fewer active requests. So among two healthy hosts randomly selected, it will select one with the least connections or requests. Okay, so basically the same thing. Traffic policy, load balancer, and a simple least connection. And you can have multiple load balancing rules, just like we've seen in here. So global and version specific one. So that's what we're going to cover. So destination rule here, and a service level traffic policy for load balancer, and specify round robin, which is this one. This is just underneath host. Also, version specific traffic policy for load balancer, and I specify least connection for subset v1. So this is specifically for v1 only. So under subset section, we have v1, right? Name of subset is v1, and this is the label version v1. And then under this name v1, we can have child traffic policy block, and we can have least connection. Also, we can have another item in the list of a subset v2, and underneath we can have child traffic policy block, and for v2 we want to have a random. This is how you can configure multiple level parent and child level traffic policy. Next, 6.11, enabling sticky session for load balancing in destination rule. So I've mentioned in previous section here, we have talked about how destination rule allows us to customize not only load balancing algorithm, but also we can enable sticky session. So let's take a look here in 6.11. So kind is destination rule, host reviews. And then we have traffic policy block here. And then we have load balancer. And then before, it was just a simple. We have traffic policy, load balancer, and then simple is a key name, and the value was random. Right now, with the sticky session, key name of the map became consistent hash. And then HTTP cookie, name, user, TTO, 1800. This is about 1800 seconds. What's changed from a simple load balancing configuration was here changed to consistent hash, and we are using HTTP key map value. In the name, we specify name of the cookie. This can be custom arbitrary value, doesn't need to be user. And then this is the TTL, time to live, for lifetime of cookie. You define that. This is how you can enable sticky session. For this to work though, you need to have application code to use cookies, and you need to choose right cookie name here in Istio destination rule configuration. So if your application code is using cookie code, let's say custom cookie, then you need to use custom cookie here. Alright, so next, section 6.12, enable rate limiting by configuration connection. Enable rate limiting by configuring connection pool sizes in destination rule. I've already mentioned a bit about this rate limiting. So connection pool settings can be applied at the TCP level as well as at HTTP level. For example, the following YAML sets a limit of 100 connections to reviews service with a connection timeout of 30 milliseconds. So this is YAML file content, destination rule, hosts reviews, and under traffic policy. This time we have different map value. So connection pool, HTTP, and the TCP. This is what I mean by the first sentence. It could be TCP level or HTTP level. So for HTTP level, HTTP2 max request would be 1. In this case, it's gonna limit only one concurrent HTTP2 request, and the max request per connection is 1, saying that connection pool size would be 2 HTTP1 connections. And the connect timeout would be 30 milliseconds, and the TCP keep alive time 7200 second interval 75 seconds. So we can have max connection, meaning that TCP connections to be 2 maximum concurrently, whereas HTTP requests would be only 1 at a time. So we're gonna keep moving on because it's really hard to test this one, so I'm not gonna demonstrate this one. But next one, we're gonna demonstrate. Section 6.13, enable circuit breaker by configuring outlier detection in destination rule. So two different blocks, HTTP and also TCP. These are corresponding to these HTTP and TCP. Basically, HTTP services, what's going to happen is that any backend hosts that are continually returning 5xx errors for API calls are going to be ejected from the pool for predefined period of time. So basically what's happening is that, hey, we're going to route traffic to backend services. However, if they are failing, then we are not going to route traffic to those failing hosts, and we're going to keep them ejected for a certain period of time. Same for TCP. Connection timeouts or connection failures to given host count as an error when measuring consecutive error metric. So in this YAML example, it configures upstream host to be scanned every 1 second, which is this one, interval to be 1 second. So it'll do check for every 1 second. Any host that fails one consecutive time, which is defined here, consecutive error 1, with 502, 503, 504 error code, will be ejected for maximum 3 minutes. So the base ejection time defines how long they can be out. They are gonna be out from the pool. They cannot receive traffic for 3 minutes. They are in a quarantine area. And then it's gonna scan every 1 second. Once it fails, because one consecutive time, then it's gonna be ejected for 3 minutes. Here is pretty much the same from rate limiting. What's different is that we had already a rate limiting here, and we just added outlier detection section, which is a circuit breaker. This is kind of like a penalizing any hosts that are failing to respond. For this, limit of one concurrent HTTP2 request, this is a rate limiting, and if its request is overflowing, then you're gonna see errors. So let's find out how it's gonna behave, right? So, all right, so first we're gonna apply this destination rule for product page. So we're gonna copy this command here and create a shell and paste and then enter. This is for product page destination rule and it's created. So let's go to k8s first and then check configuration is valid. Click istio config on the left hand side menu and we should see product page destination rule, which is this one. Click this one and then click YAML. We should see this part is rate limiting and this part is circuit breaker. So outlier detection, ejection time 3 minutes, consecutive errors 1 interval 1 second. That's good. And if you click graph, select default namespace, display request response time, traffic animation, yes, and security, yes. And now we see this label, purple thunder label. If you click the legend, we see circuit breaker icon is this purple one. Because we added a destination rule with the circuit breaker configuration for product page, we see this one, which is what we see here in the screenshot. So how to test this circuit breaker functionality? We are going to be sending a lot of requests because rate limiting happens, it's going to kick in 1 request per time, and then if anything fails, then they're going to be showing errors. So what we're gonna do is create a folio pod. This is kind of like a curl pod on steroid. We can do a little like kind of like an Apache Bench command where you can send a lot of traffic at once. So what we're gonna do is to grab this one, kubectl apply-f, and paste in here. So it'll go back to a previous directory and then go to ECO 1.67 binary folder and samples HTTP bin sample client for your deploy. So this YAML file is already provided in Istio installation folder, and it created Fortio. Expand this window, and then we see Fortio deploy port initializer, and it's gonna be healthy pretty soon. Running, which is good. 1 out of 2, 2 out of 2. Okay, that's good. So what we're gonna do next is to test curl the booking for product page URL. So we're gonna copy these. So basically, it's setting a Fortio pod environment variable, and so we can print this out. Echo Fortio pod. In the same way, we're gonna get booking for URL and then save this in an environment variable. All right, and after that, we can also echo this one, echo, and this is the URL endpoint. And what we're gonna do here is to this command, kubectl exec into this pod's container. Container name is Fortio, and inside this container, we're gonna execute Fortio command, which is found under user bin, and we're gonna pass arguments load -curl and booking for URL, which is set in the previous line, booking for URL. So we're gonna copy this one and enter, paste. All right, so it did actually make a curl request to this URL and then product page. So this is just a normal curl response, HTTP 200, and this is the HTML file returned from a booking for web page. So this is just a testing. It worked, which is okay. Now we are going to make tons of requests. So again, we're gonna get a shell into this Fortio container, and instead of using load-curl option, we're gonna be doing load-c. This is a concurrent connection to these two. We're gonna send total number of 20 requests with 2 concurrencies to this URL. So because we have already set rate limiting to accept 1 concurrent request, yes, and then for TCP we accepted 2 maximum connections, right? So some of them should fail with 2 concurrencies, all right? So create a shell, paste ccube exec, and then load 2 concurrencies and total number of requests to be 20, and then enter. This is gonna print out a statistics as well. So here we're gonna see a whole bunch of metrics, and what's important here is here, code 200 and a code 503. So here we see code 200 to be 90%, but so this is 18 requests because we sent a total of 20 requests, right? And out of 20, 2 requests failed. So 10% failed with 503, okay? So some of them failed because of the circuit breaker feature. So these failed requests were trapped by circuit breaking. So if we increase the number to be, let's say, 50 or something like that, then we're gonna see much more higher percentage of failure. So if you do, let's say, 5 concurrencies and 50 requests, and then we're gonna see much higher failure rate. This is because of the circuit breaker feature. All right, so we see 24% failing and only 76% succeeded. So let's go to query request and then refresh this page, and we should see some of the requests failing. Everything's green right now. It's because internally all the requests internally are successful. But at this point, some of the requests are returned back with 503. So that's why we don't see any errors, okay, red one, because anything internal one is successful. So anyways, so this is how you can configure rate limiting and also circuit breaker and how to test it.